Last time we talked about photoelectric effect, which demonstrates that light behaves like particles, that is, it is made up of photons. So the question arises, how many photons are there in light? To answer this, let's reformulate the question in a practical sense. The question now becomes, how many photons are there in a light pulse of energy 100 joule from a light source, say laser, of wavelength of 450 nanometer. So given the question, now let us see that we are given a light of wavelength of 450 nanometer, and 450 nanometer corresponds to violet light, which is visible to us. So we are basically talking about violet light photon. Secondly, the light source, which is a laser, it ejects light pulses, each having certain energy, and here that energy of a single pulse is given to be 100 joule. So we can calculate the energy of a single photon by just knowing the wavelength of light or frequency of light, because energy of a photon is directly related to the wavelength of light, and the formula is energy of one photon E1 here equals to h nu, where h is Planck's constant, nu is frequency, and then that frequency is directly related to the wavelength. So by just putting these values, Planck's constant, velocity of light, and then wavelength of light is 450 nanometer, we get the energy of one photon. So you can see here, energy of one photon is very small. It is 10 raised to power minus 19 joule. To get a physical sense of 10 raised to power minus 19 joule, we should look into how much is 1 joule of energy. So 1 joule of energy is the energy that we consume when we lift an apple of 100 gram by 100 centimeter. So you can try to lift an apple of 100 gram by 100 centimeter at home and then see how much energy you consume. So it's very tiny amount of energy, and in general, a healthy person in a day consumes around 8000 joules of energy. So now you can imagine that out of 10 raised to power 19 parts of 1 joule, the one part represents the energy of a single photon, and that energy is extremely small. So now if we have the energy of a single photon, we can get the total number of photons in a light. So we already know the energy of a single photon. Just divide the energy of a single pulse, which is 100 joule, by E1, energy of single photon. So we would get number of photons around 10 raised to power 20. So we have around 100 quintillion photons in light. In the present case, it is violet light, so we have this much of photons in the violet light. So it's extremely high number of photons are there. Next question is, how to increase or decrease the number of photons in light? To do that, we just increase the intensity of light. Secondly, how to increase the energy of each photon? Just vary the frequency of light. And lastly, we used Planck's constant in our calculation. So there is a physical significance of this Planck's constant. So we'll be talking about this physical significance and importance in the next video. Thank you.